Classic IB. Let's take a really easy question and make it confusing by adding extra details. The extra detail in this case is the helicopter. So check this out. We have this helicopter ascending at a constant rate of 12 meters per second. And the only thing you care about this helicopter is the 12 meters per second. So what we're going to do is we're going to actually solve the problem with this package that gets dropped. We're going to totally not even bother to draw the helicopter, and here's why. Let's give the package an initial upward speed of 12 meters per second. And what we're going to say is gravity, the acceleration, we'll just use -10 here just to do that. Okay, we'll take 2 sig figs. So, whoops. -10 meters per second squared. And then here's the other thing. Since downward is in fact the positive direction, we're going to say our displacement is -64 meters. So what we want to do is figure out the time it takes the package to reach the ground. So here we go. Essentially, we're going to have that S is 1/2 AT squared plus UT. -64 is going to be -1/2 times 10 times T squared plus 12 times 10. And we have this quadratic equation to solve. So we're going to have 5T squared minus 12T minus 64 equals 0. And we're just going to judiciously apply the quadratic formula. So to get the time, T is 12 plus or minus the square root of 144 minus 20 times -64 all over 10. And it's up to us to go ahead and actually solve out this quadratic formula, which I'm going to do when I get my calculator. And so with this in mind, I'll take 20 times 64 plus 144 . And then when we square root that, we end up getting 37.7. So 12 plus or minus 37.7 divided by 10. We're only going to end up getting one positive number here. And so I'm going to end up getting, if we take this out to 2 sig figs, 5.0 seconds to hit the ground. All right. So that's the answer that I'm getting to number 7. And I will now publish these solutions to Haiku, where they will be available the day that you hand in the homework.